Welcome. Today we're going to walk through an Arduino project that we receive sensor data from and also control some LEDs. We have a simple actuator with a state-of-the-art gauge in paper on top of that to show how much light we have coming into the room. And so if we cover up this photoresistor here, we can see the actuator respond to that. And we'll talk about how we got that. But it's a fairly simple circuit. We have 4 lights, blue, green, yellow, and red, and then we have the 2 sensors. And we're just using the Arduino Uno here, and we've uploaded the program. Now, in terms of the sketch, this is the sketch here that we have, and this is what the uploaded program is. And so in our setup routine, we're just configuring the servo, we're attaching it, we're configuring the 4 pins for the LED lights, and we're doing some calibration on the photo sensor, and then we're opening up the serial port so that we can communicate from the Arduino. In the loop, we're just getting the 2 sensors. We're reading the pin for the temperature, reading the pin for the value on the photoresistor, and then we are doing some conversion, and we're converting that sensor value for the light into 0 to 180 degrees, and that's how we get our servo position. But then we do a little bit more here. We're actually going to send out the information. We're going to precede it with a sensor name, and then we're going to stuff the 3 values for that sensor into a comma delimited line of data and send it out to the port. We'll do the same thing for the light sensor. And then we're going to look for messages received. We have a serial port query. We're looking for a serial event. This is pretty standard stuff that comes with the available library in Arduino. We look for the available data on the serial port. And then based on that information that comes in, if there's anything received, then we look at the information and we consider that a command. And based on that command, we take action and do certain things. We also communicate back with the serial port and send to the system, any system that's listening, and sending the commands that we have in fact received it. And we preface that with another a prefix that is an indication of a message, a system message, and that way we can capture that and get some feedback from the Arduino. And then if we've got a blink pattern, we enter that blink pattern, and then we close out that loop with a little bit of a wait time. And so that's basically the script there. And now let's take a look at real-time. So we are looking at TinMan RealTime. We've got the application running. This is version 2.0, and you know if it's version 2.0 if you have an earlier version because you have new COM source here under Data Sources and Settings, and you also have a new CSV source. Whereas in previous versions in the first generation we had a UDP source and a UDP target. Now we've added the COM sources and targets and CSV sources. So these are data sources for reading and plotting in gauges and templates and things. So what we want to do first is we want to open up that port. Let's just simply say new COM source, and the new COM data source wizard is presented. We're just going to look for the available ports. We see that Arduino is sitting on COM 7. We can leave things default here, 9600, 98, and 1 for the baud rate parity data bits and stop bits. Go to the next screen, and this is essentially saying if we're going to be reading this port, we need to be able to parse this data. And so there's a certain structure to that message, and you have complete flexibility here. We know that the messages that we have designed in the sketch, they contain, if we look here, they are preceded by the name, a text name of the sensor, and they're comma delimited. And so here's temp, and those are 3 values, and then light. And so we want to leave them as a comma delimited message format. The content, we're not sending multi-sensor messages. They're just 1 sensor per message line, so we just leave that blank. And we're not preceding all messages from the Arduino with 1. prefix. We do that if we have multiple Arduinos sending to the same location. But we do know they have string IDs, and that's a sensor identifier, so we leave that checked too. And so we click Next, and it says we're successful. And it also reminds us that we need to import sensor data templates and various other things to identify individual sensors. So we click Finish and click that, and there's the data flowing in. And we can see that it's going a little so fast. We can see that it does have light and temp. Those are those two prefixes, and it looks like 3 comma delimited values. And so we see that that port's already opened up, and we've got a green light on the target as well, so we can receive data and we can send data. But we need to put some gauges on the screen before we can actually do that. And so down here in our data source pane, what we want to do is not just add individual sensors to look for. I've already created a spreadsheet with the sensor descriptions. And if we just look at this real quick here, let me just launch this in. Temp, light, and message. I'm going to do the same thing for some commands here we've already structured. And there they are. You've got some command names here. And these command names that we've just added in correspond in this sketch to this kind of portion of the loop in the Arduino Sketch, and when a message is received, it's looking for specific strings, and you can see here are the names of those commands: all, none, RY, GB, pattern on, pattern off. Here are what you do when you receive those. It's pretty straightforward stuff. And so let's just get started here. And one of the first things that we can do is just add a stacked values sensor reader. Just gives you all the values for each of the sensors that you choose. So we're just going to say, let's select COM port 7. This is auto-populated with the information from that particular data source. Select a sensor from that source. We'll choose the temperature, and we can see there are those 3 values that are on that line. And there are those coming in, being parsed. Let's do the same thing for the photo sensor, our photoresistor, and we'll choose that. Boom. Now for the written text message, we're going to use a text value control because it handles the data in a different way. And that's the system message, and that's text. There's only one value there. And it's not sending anything back, but we could add a command button here. And for this command button, let's have this correspond to blink blue, and or turn blue on. And we'll select the UDP target, and let's go into commands. Here are our commands. We'll say blue, and we'll choose that, and we'll go ahead and do that. And so we can look at the Arduino now. The blue light is on, and it gives us this response turning blue light on. And that came from our Arduino Sketch right here. When that input string equals B, which in fact it does when we press that button, the message that it sends back a string, I am going to turn the blue light on, and then we actually do that. And so this is a great feedback mechanism that you can build into your projects and robots, etc. Let's add a few more buttons. Let's have one be the blinking pattern on, and we'll choose this. I don't know if we're going to fit in on that button. Yeah, we're a little bit over the edge there, and we should get some blinking lights. There we go. It's a little bit like an emergency response vehicle. Let's see, and then we'll say blinking off, and we'll select a target and the command off. And there we go. And so you can see that the feedback here, and let's reduce the size of that text so we get it some, make it a little bit bigger. And let's give the background color a dark red, and maybe the value color a white. Okay, and let's turn these things off so it stops. There we go. So we just look at that red thing, and that'll tell us what it's doing. So there's the blue light on, turning blue light on, blinking pattern on, blinking pattern off, blue light on, and let's do one for the red light. And we can also, rather than choose one of these commands, we can try some different things. We can use this custom command here. Let's choose red. There's the red light, and so you don't have to import a bunch of commands. You can just do them on the fly G, we know that one's also a command. That turns the G light, the green light on, and then a Y turns the yellow light on. And if we look back here, it says turning yellow light on, so it's already responding. But I'm just going to make it nice and easy, because if you have a lot of commands, and in some cases we've worked on systems with thousands of commands, you want to do it in an imported list. But anyway, so there's the, I think, did I choose the right one? No, I want to choose yellow, and we'll make that yellow. Okay, that's the command there. So we've just got a couple of these things. You can see how as I click on these different buttons, we get the type of system response, and the system gives us the information back: stopping light pattern, starting light pattern, turning blue light on, turning yellow light on. Now the next thing we can do is add a chart here. Let's add a rolling chart for the, let's do this, the light value, and we'll do the raw. We know that goes up to 1200 or 1024. Let's just use 1200 and 100 as increments, and we go in here and we add a data line, and that's the photoresistor sensor. We're going to just choose the value, and we'll have that be dark green, and we'll show that in the legend. And so there is a dynamic chart. Let's just bring all these things over here. See if I can move these guys. Might not be able to while it's running. But if I just cover this up with my hand, you can see the impact to the value on the light sensor. And if I turn the light off here in the office, it goes down just a little bit as an average level, and then if I cover that up, it's even more. And then if I get closer to it, you can see the kind of changes that we can cause. And so, and we still see our the kinds of things that we were hoping to see with the photoresistor sensor as it responds to the touch. Okay, so that's essentially it. I think when the blinking pattern is on, by the way, the actuator doesn't move because we're trying to conserve a little energy. So now once we've turned that blinking pattern off, we get a little bit more of a responsive actuator, and so you can see that. Okay, all right, so that's a quick overview of the technology and kind of the ease with which you can connect with these systems. There are many other gauges that you can add to the screen, and just setting their properties is as simple as choosing your data source, temperature, perhaps that's degrees, and there we have the temperature. It's in the wrong type of gauge, and so we'll go 0 to 100. And so then we got our temperature gauge there. I'll go 0 to 120. So that's a quick overview of the technology, and hopefully that's meaningful for you. But this is an excellent way to build a system and have that system respond to you and have a direct, full feedback and actuator responsive loop with sensors. Thank you.